Hello everyone, from the Novedge team, welcome to today's webinar. What's new in Mathcad Prime 4.0, Maximizing Engineering Efficiency. This webinar will provide an overview of the new features PTC Mathcad Prime has to offer, including content protection, interoperability with third-party applications, improved usability, and improved performance. Today's webinar presenter, Luke Westbrook, joined PTC in 2014 as a PTC Mathcad Application Engineer. He has a major in both physics and engineering physics, with a focus on mechanical engineering and a minor in mathematics. You are definitely in good hands today. Before we get going, here's an overview of what we do at Novedge. Novedge is one of the largest online stores for design software, and we offer a huge assortment of software solutions that cater to virtually every designer's need. So come check our webpage at novedge.com. And for more daily software news and limited time promotions, follow us on Facebook, Google+, or Twitter. Coming up next week, effective animation production with Moho Pro. Last but not least, today's webinar is free and is being recorded live. So if you want to rewatch this or any webinar episode, just head on over to Novedge's YouTube or Vimeo channels. And now let me pass the screen to Luke. And he will start right away with Mathcad Pro 4.0. Enjoy the show.
Okay, great. Thank you very much. So first I'm going to start with a couple of slides just to kind of introduce Mathcad. I think on the phone we might have, people who have different experience levels with Mathcad. So I just want to introduce, first what is Mathcad before we get into kind of what's new, right? And so the first thing I want to talk through is really from a high level what Mathcad is. It basically takes kind of the familiarity of your engineering notebook, right? If you've got your engineering paper and you're jotting down notes and that sort of thing as you're performing calculations, making design decisions, and that sort of thing, and so you're able to kind of write things down, your text and math and all that stuff, right? It's a piece of paper. You can put whatever you want on there. The trouble is that that's not very digital, right? And so then what happens is, you're trying to run your calculations in a way that's digital, reusable, and that sort of thing. But then you're stuck with something like Excel, right? You're looking into different spreadsheet cells, and you're playing Battleship with, cell A29 times B32, and you don't know what those mean, right? So what Mathcad does, it kind of digitizes the idea of the engineering notebook, where you can take your math and your text and everything you need to document your design intent, and actually puts a really powerful mathematical engine behind that, right? So it's digital, it's powerful, and it runs your calculations live, so you can perform all your calculations and still keep those visible and see what exactly is going on, rather than going through kind of the cryptic cells, spreadsheet cells, or maybe a computer language or something like that. So that in a nutshell, that's kind of what Mathcad is. And obviously, if you're not familiar, I'm going to get into the software in just a minute. But and so hopefully, you'll be able to see kind of more what I'm talking about visually. But I wanted to just kind of set that foundation and let everybody know where we're at there. And so then let's talk real quickly, and I'm just going to give a brief overview of what is actually new in Mathcad Prime 4.0. We released that back in March, and so this is the latest and greatest version of Mathcad Prime. And so really from a high level, what Mathcad does is it allows you to show, solve, and secure your engineering calculations. So some things that we've introduced is content protection, the ability to interoperate with third-party applications through a couple of different ways. Improve usability especially through being able to break equations. We've also got performance enhancements as well as support for Windows 10. So that last one, Windows 10 support, I'm just, there's nothing really to show there. It's just, hey, if you're on Windows 10, we now have Mathcad supported on Windows 10. So there we go. Check that off the list. So then the other thing, and I guess I'm kind of working backwards, I guess, from the last slide, is performance enhancements. It's not necessarily something that's particularly easy to show through a demonstration, so I'm just kind of throwing this slide up here. Basically, with previous versions of Mathcad Prime, what would happen is sometimes if you had really long worksheets, you know, some of the performance of just interacting with those worksheets would slow down. You know, things such as, you know, moving between, you know, page mode and draft mode, you know, collapsing and expanding areas, collapsible areas, as well as kind of moving things around the page, right? And so with Prime 4, we've added a lot of improvements in that, so that, you know, if you have long worksheets, you really shouldn't notice, you know, some of the lag that you might have noticed in previous versions. So this is a really really powerful thing, especially if you're using you know, longer worksheets. We've also included some plot performance improvements, right? So with Prime 4.0 plotting, you're able to plot 2 million points per trace versus the 500,000 in previous versions, right? So 2 million points is a lot of data, right? So you're able to really do a lot with that. So that's really great stuff. Okay, so those are some of the things, you know, I wanted to show in kind of PowerPoint form. But my personal preference whenever I'm giving a demonstration or whatever, Mathcad is made to be seen. So what I'm going to do is I'm going to switch over to Mathcad. And what I'm going to do is, I'm going to step through a couple of different worksheets and kind of highlight both core functionality, things that have been in Mathcad since the dawn of Mathcad, as well as what's new in Prime 4. So if you're familiar with Mathcad, then you'll be able to see kind of what's new. If you're not so familiar, then hopefully this will still give you a feel for what Mathcad is and how you might be able to use it in your day-to-day processes, right? And obviously this is from a pretty high level, and so, you know, we're not going to be able to get into a ton of depth here, but at the same time, you know, hopefully you'll be able to kind of, you know, connect those dots and that sort of thing, right? So what I've got here is an example from Rourke's formulas for stress and strain, right? This actually comes from the 6th edition, and this is actually something that's now available, is a set of worksheets available for Rourke's formulas in Prime 4 format, right? And so you know, you can take a look at this and hopefully see this as kind of an example. So first, you know, here's Mathcad, right? And so you're seeing this worksheet with text, right? I haven't shown any math yet, but we've got text here. And so what that is really it enables us to document what exactly we're doing, right? We've got some descriptions here at the very beginning saying, okay, this is what we're doing, and this is, you know, where this information comes from, and so forth, right? So then as I scroll down, you can see I've got this image here that I've pasted in here, as well as, you know, a footer giving, you know, copyright information and worksheet information, right? And all those things, if I just double click on the header, you know, or the footer rather, you know, I can make edits to that, and, you know, I can double click back in the worksheet to go back there, right? So everything is very, very user friendly. Like the user interface is very, very intuitive, easy to pick up on, right? So I'll scroll down, and now we actually start seeing some math, right? Well, not necessarily math, but we've got some variables defined here, right? The moment of inertia, the area of the cross section, our shape constant, distance between axes, and that sort of thing. Now, what you'll also notice is that there's units attached to, well, not each of these, but where units is expected, you know, you wouldn't expect units in a shape constant, but where units are expected, you see those units attached, right? Now, something else like Excel is not really going to be able to handle that, right? You need to be able to put numbers into something like Excel according to whatever unit you're using, right? Whereas Mathcad has the ability to actually be intelligent, be smart with how it handles units. And so I'll show that more in just a second, but I'm kind of, you know, want to set the stage here as we move forward. And so, okay, so I've got all these inputs set up. Everything's good to go. I've got my loading. I've got my my angle for my vertical load, modulus of elasticity, all that good stuff. So scrolling through, now we can see some actual math happening, right? So first we start with some of the basics, right? And then we can see, okay, what I've actually done here is this if function is a built-in function in Mathcad. And there's some, 700 built-in functions, and I can go to the functions tab and open that up. And here I've been looking for some random number generators, but here I can back out of that, and you'll see the entire list of built-in functions, right? Or the groupings for them, right? So I can, okay, look at, all right, what do we have in terms of, differential equations? Okay, I've got all these different things, right? So there we go. And so what this if statement is doing is it's, doing kind of what you'd expect, right? It figures out if this is true or false. If it's true, it returns this first value. If it's false, then it returns this, right? Kind of an if-else statement. Now, there are other ways to do that in Mathcad, such as putting in some programming operators. So I can just go in here and I can say, all right, if, and then I can go to the next line and I can put, else if, and then I can go to the next line and I can put in else, right? So I can add this programming structure, these logical statements that allow you to perform a different calculation depending on a different situation, right? And so you can also use while loops and for loops and that sort of thing. But in this case, I've just used kind of this inline function since it's pretty simple if-else statement. And so moving through, again, you can see how Mathcad uses this natural math notation, right? Imagine what this guy right here might look like if this were in Excel, right? This is not a particularly difficult equation by any means, but having to figure out, okay, what is this cell reference, what is that cell reference, and that sort of thing can get really, really cumbersome. So as I move through, what we can see is, all right, so I've got some more equations here, and now we start getting some real stuff. And what you can see is here, this last equation, it's actually running off the edge of the page, right? So what I can do is I can click on it and I move into draft mode, and so I can see that whole thing. But that's not really what I want. So this kind of brings me to one of the new things in Mathcad Prime 4.0, which is the ability to wrap an equation. Now, if you're familiar with Mathcad 15 or earlier, which is kind of what we call the legacy version of Mathcad, you might remember that in that software you could wrap an equation only on a plus sign. But what we've done in Mathcad Prime is really what we've wanted to do is make it a little more intuitive and a little bit more robust, right? And so now what you can do, and if I go down to the operators dropdown, you can see I've got equation breaks for plus, minus, multiplication, and inline division, right? So I can insert these as operators, or what I can do is I can just press this equation break button. And you'll see as I hover over that, it says Control-Shift-Enter, which is the keyboard shortcut for equation breaking, right? So you can use either one, either the button or the keyboard shortcuts. So if I click this, you'll see it'll toggle, the wrapping, right? It doesn't change the actual math of the equation. It just changes the format. So then I can take long equations and I can fit them onto one page. And again, I can do this for not just pluses but also minuses as well, right? So multiplication, subtraction, inline division, that sort of thing, right? In this case, I'm just going to use a plus sign because I think it kind of breaks it at a logical point there. But you can, again, the point is it gives you a lot of different opportunities to change how you format your equations, and it doesn't have to just be in on this kind of single line. If I'm in a denominator here, I can also break it there, right? It doesn't make too much sense in this particular instance, but the point is basically anytime you see a multiplication, addition, subtraction, inline division, you can break the equation at that point, right? So this really gives you a lot of just better handling of the equations that you want to write, better control over that. Okay, so now that I've got that, I'm on one page, so I'll go back into page view, and I'll keep scrolling through, and really what I want to do is just kind of take a look at some of the different pieces of functionality here real quick. And so here what we can see is my case 5J for this worksheet from Rourke's formulas. What I've got is some setup, right? So I've got left end fixed, right end fixed, so my horizontal deflection is 0 inches, vertical deflection is 0 inches, angular rotation is 0 degrees. And then I've got some equations set up in a solve block. So what a solve block does, it performs some really powerful algorithms in the background to allow you to, what it sounds like, solve for equations, system of equations, that sort of thing. Now this right here is just a system of linear equations, but you can also solve for systems of nonlinear equations as well, and giving it some guess values, and we set up the constraints as our equations, and then use the find function to actually find those values and then pull them out of that solve block. And so here what we can see is the solution to these equations. Now, remember I've been talking about units, and you can see that my units here, Mathcad runs the calculation through the solve block and gives me results with the appropriate units, right? So it gives me the force on the horizontal end in pound force for the vertical end reaction as well, and in the moment it gives me pound feet, right? Now I could also, if I wanted to, I could see this instead of pounds, I could see this in newtons. So I just change that and I evaluate it. I can do kilonewtons as well, or I could go to kip, all that stuff, right? And if you're not familiar with what units are available in Mathcad, you can just go to this units drop down and find, okay, you know what, I want to see what all force units we've got. So we've got, kip, pound force, ton force, newtons, meganewtons, all that stuff, right? And so I can change that, and Mathcad performs those conversions for me so I can see the value in whatever unit I may want. But what happens if something upstream changes? Does it break anything? Well, the answer is no. So if I go back up to the top to these inputs, well, let's take something simple. And so I've got this radius of curvature that's 10 feet, right? So now I can evaluate that, and it's going to give me 10 feet. I can change this to meters. If I want, I can change it to inches, what have you. But you know what, instead of defining this in feet, everything else is in kind of US customary, feet, inches, that sort of thing, but it doesn't really matter. Mathcad will take whatever unit and run the conversions in the background. So if I type in, instead of 3 feet, I type in 3 meters, what's going to happen is, if I scroll down here and then click outside, you're going to see these numbers are going to update ever so slightly, right? Because the calculations have now changed, and Mathcad is performing a slightly different set of calculations because it's got a slightly different number, right? 3 meters instead of 10 feet, and you saw those numbers update, right? It runs through the solve block again and it updates, right? So this worksheet is live, and everything at the top will propagate down and change as you go. So what you can do is you can set this worksheet up as a template, say, hey, this is a calculation that we want to do pretty frequently, and so then what you can do is you set this up, and then these values can be changed as needed. So you can save this as a template file, put it on a shared network drive or whatever to kind of streamline it and really really kind of standardize the calculations that you're doing on a day-to-day basis, right? But this kind of brings me to the second point of, well, this is all well and good, but if I send this to somebody else, if I send this worksheet, yeah, okay, they can change values and change the radius of curvature and change some of the parameters, but but this is a set of verified calculations. I want to make sure that if I'm sending this to a coworker or a supplier or something like that, I don't want them making changes to the calculations themselves because they may not get a right answer. But if I know, hey, these have been kind of given a stamp of approval, then what I can do is I can take some calculations and I can secure those, right? And that brings me to kind of the next thing that's new in Prime 4. So what I'm going to do to that end is I'm actually going to go ahead and copy everything in this little section here, and I'm going to go ahead and I'm going to cut that. So Control X, and there we go. Okay, so now what I'm going to do is I'm going to go to Document, and I want to insert an area. And now I'm just going to paste in everything that I just cut out, right? So now I'm in this collapsible area, right? Same information, but I'm in this collapsible area. Let me move everything over to the side here a little bit so we can get that just a little bit more centered. All right, there we go. Let me remove some space up here. And so now I'm in a collapsible area. And in previous versions of Mathcad Prime, all I could do was just expand, collapse, right? So I could tuck it away if I wanted, or I could, let it be displayed. But now with Prime 4, we give you some extra control over your calculations, right? So what you can do is you can right-click, whether inside the area, or you can right-click on this collapse icon right here. And what I can do is I can, collapse it, or I can protect it. So when I click on this, let's say, and again, just kind of the setup that we have right here is these calculations in this area, we're going to assume that these are verified, validated equations, and we don't want anybody changing them. All right, so let me go ahead and protect this, and I will type in a password. So I'll just type in 123 just to make things simple. And I'm going to show this timestamp, and I'm going to unselect this. I'll talk more about that in just a second. But now what I'm going to do is I'm going to protect this area. All right, so now I've got a password protected area, and it gives me a timestamp here for when this was protected, right? So okay, May 31st, 2017, 2:20 p.m. This is when the area was protected. Okay, so now what happens is I can't do anything with this area now. I can expand it and collapse it, right? But you can't tell, but I'm sitting here trying to click inside and nothing's happening, right? I'm trying to drag, and I can click and drag, and I can highlight everything here, but I can't highlight this area, right? I can't delete it. I can't edit it. It's protected, right? So what happens if I send this to you and you don't have the password? Now I've just told you the password is 123, so you do have the password. But if you don't have the password, then suddenly you can't make any changes. Now what you can do is you can change things outside of it, right? So if I change this back to 10 feet, when I scroll down here, and I'm going to click just outside of the region that I just changed, you're going to see these numbers will change, right? So you can see that while my my calculations they still work, I can't make any edits, right? So I know that the values that I'm getting out of here are correct, right? Now if I want to unprotect it, then I just right-click, unprotect, and I type in 123, which is my password in this case, and there we go. Now it's just an area. But now let's say I want to do something else. Not only do I want to, I'm gonna copy these here, and let me bring this up, paste these out here. Okay, so bring these outside of the area. Let's say, okay, not only do I have these set of calculations that I don't want anybody changing, but you know what? Maybe these are proprietary calculations, and I don't just want people to not be able to change it. I don't want people to see it, right? So maybe I'm sending this to a customer or a supplier or something like that, and I want them to be able to use the calculations without actually being able to see what's on the inside. So then what I can do is I can protect this area, and in this case I'm not going to, the password's optional, so I'm not going to do that in this case, but I will lock the area display state. I'll still show the timestamp, and I want the display state to be locked as collapsed. So now I'll protect it, and now I've got this protected area, and I can't access it, right? I can click on this plus sign all I want, nothing happens. I can try to highlight, nothing happens. I can't do anything with this area. It's protected. Now again, it's not password protected in this case, but obviously you could and probably would if this were the use case that you were using. But again, I can't see the calculations here, but they're still there, and Mathcad knows what to do. So if I go back up to the top and change this to, say, 3 meters, then when I click outside, I'll scroll down here, I click, and suddenly what we see is the calculations are running, and these values get updated with whatever's on the inside of that area, right? So even though I can't see it, I can still use the calculations. I can still use that math and get the numbers, the outputs that I want to see without being able to see what how the sausage was made, so to speak, right? And again, if I want to unprotect it, in this case, there's no password, so it just kind of gives me this prompt, says, hey, are you sure you want to do this? Yeah, okay, then I unprotect the area. But again, obviously, and then I can expand it and collapse. But I can also do that with a password or not. Right. So this is a really beneficial and powerful feature to make sure that your standardized calculations, your proprietary knowledge, isn't changed without your awareness, or even isn't seen without your wanting it to be seen. Right. So you can really kind of maintain some control over your calculations and then protect that content and that knowledge. So there's that. So let's go ahead and do a little bit more scrolling through here, and so here we can see, okay, the next case, and you know what? Just as another way to talk through kind of the units in Mathcad, we've changed the units, but what Mathcad also does is it's not just units aware or units compatible, but it really is units. It has an intelligence with units. So what happens is I've got this error here, and when I click on it, Mathcad says, hey, these units aren't compatible. Well, the reason is this right here is a dimensionless number, and this guy is a force as well as this. Now this also is dimensionless number. So what I'm doing is I'm adding a force plus a dimensionless number, which doesn't make any logical or mathematical sense. So Mathcad understands that. If you try to do something like that in Excel, you're going to get a number, but you're going to get the wrong number. So Mathcad keeps you honest. It says, hey, you know what? These units aren't compatible, so figure out what you did. And it tells me where that incompatibility happened. So I can look through this and say, you know what? I totally forgot to multiply this by the vertical reaction force. All right. So then once that's done, I'll click, and now I'll get my value, my angular rotation in degrees. Now let's say, you know what, instead of, that made no sense, but let's say I just mistype something. So I do r cubed instead of r squared. What's going to happen is I'm going to notice something very quickly. Suddenly I'm getting feet times degrees, which is obviously not appropriate for an angular rotation. So no, this isn't an error, but the thing is, with those units, I can see, you know what, something isn't going right. So let me go back to this definition for the angular rotation and see what I've done wrong. Right, okay, so I've accidentally cubed this r, and it needs to just be squared, and so then I can change that, and then my degree, my angular rotation is back in degrees, right? So, yeah, so that's kind of that, and I'll kind of, there's not really a ton else to see here other than what I've shown, but hopefully that kind of gives you an idea of, you're seeing a lot of different calculations that live math, that natural math notation, as well as how Mathcad handles those units. And kind of along the way, again, we've been able to talk through being able to break your equations, which is new with Mathcad Prime 4.0, and the ability to secure your content through being able to lock, to protect and lock an area, collapsible area. Okay, so let's now shift over to a different worksheet that I have, and so we can highlight some other pieces of functionality, both new and kind of core pieces of functionality, right? So what I've got here is some calculations for a PID controller. All right, so I've got an introduction here, and I've got here what looks to be just an image, right, giving me a schematic of this PID controller. But this is kind of the new thing in Mathcad Prime 4.0. If I go to the Input-Output tab, what we can see is kind of a new set of options here in this objects group. This wasn't here in Prime 3.1 and earlier, and so now what I can do is I can insert an object, right? So if I click here, what I can do is I can go ahead and create new. If I want to, find a new, Visio drawing object or something like that, or I can create from file, and I can, browse to something like a PowerPoint or a PDF. I wanted to embed that into my worksheet or something along those lines. So what I've got instead is I've already got this this guy here, which is it's a Visio object, right? So I can double click here, and you'll see that it says object here. And so now that I've double clicked, it's popped up in my other monitor. But here we can see that in Visio it launches this, and so now you can see what is actually embedded into Mathcad. So now what I can do is I'm not going to make any major changes because the schematic is kind of how I want it to be. But what I will do, just to kind of make the point, is I'll change the design a little bit in terms of just something simple like color aesthetics, right? So I'll click on this guy, and I'm going to make this kind of a bright orange color because I really want this image to pop. Sure, why not? So then what I can do is I'll just save it and close, and now you can see that this has been updated in my Mathcad worksheet, right? So this is actually embedded within Mathcad. It goes with Mathcad wherever I may want. Now I do have the option anytime I insert an object, if I create from file, I can actually link it to the original file. So if separate from Mathcad, anything that file changes, what I can do in Mathcad is I can just say, all right, click on an object, and I can say update link, right? In this case, they're up to date, so it doesn't really matter that much here. But that's kind of a new something new that you're able to do, right? So really what then you can do, instead of just putting images and that sort of thing, Mathcad can really kind of be a centralized location for a lot of the different work you're doing, right? So you can embed embed different objects, different components to your calculations, and then just double click them and have immediate access to them. Now, if you're familiar with Mathcad, you might recognize this is kind of similar to something that's been around for a very long time, which is the Excel component, right? So if I just, I'm just going to actually open up a new worksheet here just to show this off. But I've got my input-output here, and I've got an Excel component. So what this is, I'll insert this, and it runs a little bit differently, right? So the Excel component is very similar in that it's embedded with, effectively it's an Excel worksheet, a spreadsheet embedded within Mathcad. And if I double click, again, it's going to show it up on my other monitor again, but it's going to launch that worksheet in Excel. And I've got inputs and outputs, right? So if I just if I just insert, for example, all right, I'll say cell A1 is going to be equal to pi. What's going to happen is Mathcad's going to populate that. So if I double click, you can see that, okay, I'm updated there, and I can highlight that and all that sort of thing. And then I'll close that, and there we go. So I've got that updated. I can format this, and obviously this is a pretty silly and trivial example because it's just one value. But I can also, if I really wanted to, pull stuff out of the Excel component by saying, all right, I want A1 to be, I'll call it pi, and there we go. And I can collapse these just like a collapsible area, and then I can evaluate pi, which, again, this is a very trivial example, but I just wanted to kind of make the analogy to where, this is embedded, and it keeps showing up on my other monitor. This is embedded inside the Mathcad worksheet very similarly to this Visio object using the object linking and embedding functionality. So anyway, so that's kind of a new piece to the puzzle with Prime 4. And scrolling down, we can actually take a look at some of these calculations, and what we can see is we're actually using the symbolics functionality. And again, this is not new. The symbolics functionality, it's part of Mathcad's core. But again, I want to make sure that we're highlighting both new and old, if you want to call it old, right? And so I've got this it's symbolically evaluated, and so here you can see the symbolic operators, this drop down, and so here is the symbolic equal sign, if you will. And so what I've done here is I've just taken this equation and then told Mathcad to solve it for y. And so it takes care of that. So then I don't have to do this on a scratch piece of paper and worry about making a sign error or anything like that. It goes ahead and does that for me. And now I can scroll back through, and actually this worksheet's pretty great because it has a lot of different examples of that. And so, for instance, what I want to do is take the Laplace transform of this output. So what I can do is I'll insert the the symbolic evaluation, and then what I want to do is I want to insert a keyword, the Laplace keyword, and then that will perform the Laplace transform of u of t. And then what I want to do is I actually want to assign this to a function called capital U of s, and now u of s is going to be equal to 1 over s. And now this will be used down here in the rest of the worksheet, and here you can see I've got an inverse Laplace being done, again, symbolically, and then we can move kind of further throughout the worksheet, and you can see the different responses here. But we've got a pretty huge steady state error, so let's clean that up, right? So we're adding some different controls and that sort of thing. And so then what that does is brings me to this guy right here, right? So here we've got the inverse Laplace of y here. So what I want to do is I want to do this again. So I'm just going to insert. I'm going to find the inverse Laplace. There we go. That's done. And then I want to assign this to another function called y2 subscript p of t. And then what I want to do is I want to go ahead and plot this here, right? So I can go here to plots, add a trace, and I'll say, all right, plot y1 subscript p with respect to tau. And then I'll add another trace, and we'll say y2 subscript p of tau. And now we can see what the output is for these new systems here, right? So now, let's say, okay, I've got this worksheet, it's all set up, and I've got everything calculated, it's all the way I want it to be. But then what I can do is, let's say I want to export this, right? I want to send these calculations to somebody who, they don't have Mathcad, right? We've talked about being able to send your calculations to somebody who has Mathcad and trying to lock up your equations and stuff that way using collapsible areas. But let's say I want to send this to somebody who doesn't have Mathcad, or maybe I need to generate a report. So what I may want to do is there's a couple of different use cases. So what I may want to do is, I just want to take a chunk of calculations, and let's say I want to take these guys here, and I want to copy those. And okay, so Control C, and what I'm going to do? I'm going to launch Microsoft Word. That's going to take a second. Let me blank worksheet. I'm going to move this over to my new other monitor so you can see it. And so now I've just got this blank worksheet. And so if I just Control V, now you can see it pastes exactly what's just come from Mathcad. And okay, so that's, so there we go. So I can take multiple regions in Mathcad Prime, copy those, and then paste those into Microsoft Word, and it keeps that formatting, right? So everything, is spaced the way you'd expect it. The text actually pastes as text, and the math regions paste as static images. So now I'll just I'll kind of delete all these, and so I can do that, but I can also merge formatting, right? So when I right-click and choose to paste, I can merge formatting, and then what that will do, instead of keeping everything, the spacing, it's just going to put each one on kind of on each line, right? Whereas before, if I do this again, you'll see that it kind of keeps the spacing and the location on the worksheet, right? So merge formatting just pastes all the regions kind of one by one in order as they appear on the worksheet. But this is only a chunk of calculations. Let's say I want the entire thing in a report. So let me go back here. So then what I can do is, and again, this is new in Prime 4, is what I can do is I can go to Save As, and I can save as rich text format. Now this button here did not exist in previous versions of Mathcad Prime, and so when I click on this, what's going to happen is it's going to show me a save dialog, but it's going to save it, have the Save As type as a rich text format. And I'll go ahead and save this to my desktop just for demonstration purposes, and I already did this earlier. So what that's done, it's actually basically copying all that's in here and going ahead and pasting or creating, I guess, a rich text format document. So I can go into Word, I can open, and I can go to my desktop and find what I've just saved, this PID.RTF, and open that. And then what we see is, wait for it to open here. Oh, you know what? It's showed up. Oh, hang on just a second. All right, there we go. Well, hang on, give me 1 second as I'm trying to figure this out. I'm not sure exactly what's going on with Microsoft Word. Let me close Microsoft real quick. Nope, don't want to save changes there. All right, let me go ahead and go to my desktop, and I'll just double click from here. I've got my PID. Now it's launching Microsoft Word. And there we go. Okay, so I'm not sure what was happening earlier, but anyway, so here is that worksheet, right? So it looks pretty well identical to the worksheet that I created in Mathcad. And again, you can see, okay, it's got all the plots, it's got all the math, right? Everything very well laid out. And again, this is free-flowing text here that I can, make edits to and document, change the documentation as I desire, right? And so I can scroll through, this entire thing here and see, here are these are the plots that I generated earlier. And that sort of thing, right? So that's a new piece of functionality in Mathcad Prime 4.0. So that's, yeah, pretty great. So basically, we've kind of introduced a few different ways to be able to interact, for Mathcad to interact with third-party applications, right? Whether it's copying and pasting or saving as RTF, or just embedding a separate file or a separate file type inside of Mathcad, like we did with the Visio object right here. So that pretty well sums up the content that I had for this. So again, just kind of to recap here, what we've been able to show is the equation wrapping, right? So improved ability to kind of format your equations as you desire. So we've introduced with Prime 4, we've introduced equation wrapping, content locking and protection, being able to protect your areas from edit or from view, even if you desire. We've also introduced the ability to copy and paste multiple regions to Word or to save your worksheets as rich text format. And then we've got the embedded objects, right? So the ability to embed third-party objects like this Visio object right here, and open those up, and then also the performance enhancements, right? So again, that was not something that's really easily demoed, but anyway, there are lots of performance improvements going on that have happened and been introduced with Prime 4, as well as support for Windows 10, right? So now it's Windows 10 is a supported platform for Mathcad Prime 4.0. Okay, so that's pretty much all I have today. So I guess at this point I will pass it back to you, Barbara, and we can, I guess, go through any questions that might have come in or anything that we may have yet to talk about.
Thank you, Luke. That was great. There's one question so far. What is the difference between Mathcad Prime and Mathcad Express, and is it worth it?
Yeah, that's a really great question. So Mathcad Express, for those of you who aren't aware exactly of what we're talking about here, Mathcad Express is effectively, it's the licenseless version of Mathcad, right? Same software, but effectively, if you don't have an operative license in Mathcad, you can still use it. The thing is, certain things won't be able to be used, right? So it kind of there's some really good functionality in the Express version, but really, if you want a lot of the more robust, I don't want to say robust. What's the word I'm looking for? I don't know. Just some of the more powerful features. There we go. More powerful features in Mathcad. Those are going to be reserved for an actual license. So the list of things that isn't included with Mathcad Express, the things that kind of shut off, is pretty long, so I won't necessarily be able to go through it. But things like, well, pretty much anything anything of any of the new features in Mathcad Prime 4. Those are only available with the license, right? So Express, you won't be able to embed objects, you won't be able to save as RTF, you won't be able to wrap an equation or lock, protect your areas. Also things like symbolics, things like the solve block that I mentioned, things like programming. These things are all locked out of the Express version. So you lose a lot of that flexibility and a lot of functionality. And then, also I said there's a bunch of built-in functions. Roughly half of those are available in Express, the other half being kind of reserved for a full license of Mathcad. Yeah, so it's a really great question. I haven't given you an exhaustive list, but at least in terms of the stuff that we've looked at today, I think I've kind of covered at least what isn't in the Express version. So definitely something to be aware of. So the Express tool is a great tool, but ultimately in terms of really being able to kind of do the things that you may need to do in terms of like commercial use, you might find yourself a little bit limited without the full license.
Cool, thank you. Also, here's another idea. If you're, are considering, the purchase of Mathcad Prime 4.0, why don't you just, you can download the trial and, test it for a little bit. It's free, and we have it on our webpage too. Go on the product page and you'll find the trial tab and give it a try. And we're so confident you're going to love it that, you'll get the real thing once it expires. So yeah, so it's always worth, test it first, and you can do it. So yeah, that was the only question. So I will take the screen back. Let's see if you can see my slide now, because I want to thank everybody for joining us today, and I want to thank Luke for the great presentation. And here's where you can find PTC Mathcad Prime on our website. And yeah, novedge.com, very easy. There's a trial tab where you can just download the trial, give it a test run. And for information on the latest specials and releases, join the Novedge network on Facebook, Google+, or Twitter. And remember, the next week we'll present a webinar on effective animation production with Moho Pro. And to rewatch today's webinar or previous ones, check out the Novedge YouTube or Vimeo channels. Our webinar playlists as webinars for every software taste. Thanks again for joining us today, and have a wonderful day, everybody. Thank you, Luke, and bye.
Absolutely. Thank you. Take
Bye-bye.
care.